I'm a bit under the weather today, so my voice might not be as loud, but we'll try to make the best out of it. So let me share my screen. Okay, before I share my screen, fine, let me share my screen, but I wanted to kind of put this notebook here in the, if you look at the charts, we will use this to sort of practice. And all you need is the community edition. I also paste the link to the Databricks community edition for you to, use for your practice. I hope some of you know about the Databricks free edition, right? You don't need any credit card. You don't need any. Just have an email address or Google account, and you can log in and start using Databricks. Let me show you. Let me share my screen again. Can you guys see this? Can you see my screen?
Yes, it's visible. Yeah.
Yeah, so this is the Databricks free edition. So you can log in and actually like play around with it. So the good thing is that we have the catalogs. We can pretty much do a lot of the stuff that we should be able to do in the real world, though it's not the same. But yeah, Tolu, you had a question?
Yes, posted a link in chat, please. A question in chat, please.
Okay, yeah. Someone just switch device. Do you mind posting the link again? Okay, sure. Let me post the link again. I'll post both links. This is for the free edition. This is for the notebook. In GitHub, I hope everyone should be able to access it and be able to download the notebook. Let me just share that real quick. Like, if you click the link to the notebook, you will see this notebook. You can click download over here. You download the file, and when you go to your Databricks, once you log into your Databricks account, you can go to your workspace and you can import. I think we need to go to the under the users. Import one. Let me see. See, you just click any notebook. You can click import. Under the file, you upload the file that you downloaded, and then it will import the notebook. I hope that makes sense. So in case you are stuck, let me know. But before we get into that, let me introduce myself. Let me show you my, what's my, all right. So my name is, Mezu, but I go by Mezu Obi. I have over 10 years experience in data engineering. I work for Capgemini. I'm part of the Databricks, they call it Center of Excellence. So one of the things I do a lot for clients is help them, architect Databricks platforms, help them in their journey for digital transformation, helping them do data analytics, data engineering, machine learning use cases, and most recently AI, right? AI, Gen AI use cases as well. So I do plan to do some free sessions like this, like on Gen AI use case when I have time. So for today, like this is one of the topics I decided to pick today is let me also tell you what I do on the side. So on the side I do coaching where like I have like bootcamp where students just let's say 5 students, no more than 10 students, just lean number of students. You could go through like 4 or 5 months of course where I teach you Databricks and data engineering in general. I try to dump all my decades of years experience within that 3 months or 4. And I offer that mentorship. Like one of the things I enjoy is having that connection with my students, having mentorship where we can interact, you can always ask questions, you can get guidance because the journey in this industry is a long-term journey. So you need the support, you need guidance and mentorship. So that being said, one of the topics that we covered in the bootcamp, which I found very interesting, was this Databricks Auto Loader. And like to be honest with you, in the projects that I've worked on, I haven't really had to work with it much, but I have a use case where we worked with it. But the reason why I wanted to do the demo today or do this kind of class or session is because it's something that I feel is actually it's not that hard, but a lot of people get scared, or you don't know what it is, or you always thought you wanted to work with it. So let's just kind of get some basics around it and actually do some basic practice and share the knowledge. And I'm open to learning as well. I'm open to your feedback, from your experience. So today, we talked about the Spark streaming in Databricks, and one of the main concepts is autoloader. So without further ado, what is autoloader, right? Let's start getting into that. Before we get into autoloader, we need to kind of go a little bit to the basics. What is real-time streaming? And why do we need to stream data, right? So a lot of times you've heard about real-time analytics, near real-time analytics. These things exist. There are use cases where companies need to make decisions in near real time. For example, you're doing fraud detection, you're doing, in my use case, we had like telemetry use case. So telemetry like means like, I don't know if that's what it means, but we had like IoT devices. So I worked for, one of our clients was a like a refinery, like oil and gas. So they have all this machinery, they have all these equipments, and they want to kind of get the analytics on how the machines function. So each machine has various data points. They call it tags. Like you give like, let's say, the pressure, the temperature, the the velocity, speed of the motor, whatever it is. Each part of the equipment has this a sensor attached to it that emits the data, and all that data can now be sent over for analytics to actually see, okay, what's going on. Is the machine gonna break down? Do some predictive analytics, and also do some kind of in near real time adjustment. Let's say you notice something is off with the machine, you can maybe try to configure the machine to be perform better based on the data that you are receiving. So we have all those kind of use cases. But so for, and that's not just, that's an example, right? Any question? Um, any question from anyone? You can ask. So yeah, so for that all these different things that we are doing, we need to get the data into the platform as soon as possible, right? And according to the Netherlands architecture, we have the raw zone, silver zone, right? Raw zone is where we ingest data in raw form, and after that, in the silver zone, we do some cleaning. And the reason why Databricks streaming was popular is this last point. Like it unifies. So if you have batch use cases, like things you are doing as a in a interval, like in a batch use case, like let's say hourly, you can combine that processing with what you do in the near real time, like your real time, like in the seconds. Because the reason is that in PySpark, it's very similar. The code is pretty much almost the same between streaming and real time. And we'll see that today. That's why they became very popular for people in the industry. So does that make sense? What I'm trying to say? Like the reasoning of the purpose of streaming. Great. So another thing you have to understand with streaming is a change of mindset, right? Like normally with streaming, we deal with unbounded tables. So it's not like the normal, in normal tables in batch, they are finite, right? Like you have the data, it's a finite set of data. But with streaming, you can think of it as a continuous kind of flow of data. The data never really gets ended, right? Like it's always, the table keeps growing. So somehow You have to change your mindset, especially when it comes to processing the data. You have to start thinking more on what subset of the data do you want to consider so that you can process it. But because in a table, it's very easy to say, hey, let me just aggregate and get the count, right? Let's say aggregate, do a group by region and count the number of records, right? That's finite in a table, but with streaming, you can't really just do that in that way, because what is your boundary? Like, because if the data keeps coming every second, so like at what point do you want to stop and say, okay, let me do the aggregation? So it's a different mindset you have to think about in streaming. But apart from that, most of the concepts are the same. Like you could still do a lot of the basic transformation like filtering, joins, they can be done. But with the Spark especially, one of the main fundamental things is they change the mindset to consider streaming as a micro batch. That's what the fundamental difference. Because there's other streaming platforms like Flink and I don't know the other ones, but in Spark especially, the concept is a micro batch. Think of the same batch pipelines you are running on a daily basis, hourly basis. Now you're running it in like every 5 minutes, every second, every 1 minute. So it's a micro batch concept to make it similar to the batch. Anyway, this is really what it is in a streaming pipeline. You can process things every 10 seconds. This is different from batch. You can also trigger available now. I really like this one, trigger available now, because it's cost effective. You can imagine, you're running something every 10 seconds. The money keeps growing, like it's always gonna be costly because the cluster stays on. But available now will process everything that it has in the backlog and then stop. So these are the different trigger modes and different kind of concepts behind streaming that you need to be aware of. In addition to that, though we're not going to get into this, but I wanted to just expose you to this, is there's also a concept of knowing the difference between event time and processing time, right? You want to know that difference because it's very important that when the data itself gets created in the source or in the system, that time is different from the time that you actually got the record, because there's the concept of late arriving data. Like it happens quite often that you might have an event. Let's say the machine something was going on, the network was down. So that time the machine was creating some records and creating data. You may not have gotten it when that happened. You may end up getting it the next day, right? So tomorrow you are getting data of yesterday. So you have to make sure that when you process streaming data, you make that difference in your code. But we for this today's session, we're not really going into all that, but that can get a bit complicated with the tumbling windows and watermarks and all that. The last thing, okay, I think we have two more concepts before we get into autoloader. Another concept is about the stateful operations. So there's a difference, like I told you, if you think of the table as unbounded in streaming, when you think about certain aggregations, certain operations that you do, now has to be, sorry, there's a stateful expression, there's it means there's statefulness, which means that you need to be aware of the previous values of that particular stream of record. Something like aggregation, deduplication, these things, somehow you need to have that a level of bounding, like a watermark, because you need to kind of say, okay, what are you aggregating over what time, over what window? You cannot just do that forever. Okay, so you need the links. Okay, can someone share the links to him? But I can share it again. Anyway, so watermark is very important. Things like filtering, you don't need to worry about that. It's straightforward to filter data coming. You don't have to worry about any way for that. When it comes to joining streaming data with static data, like a static table, there can also be complexities, right? Normal stream to static joins are the most common. It's less expensive, but what people do, like in our case, is we end up actually we get the streaming data, we just store that, and then do the rest, like the joins and all the transformations after, with all the other static table. If you have a use case where you actually need to do streaming transformations, for example, like fraud detection, right? That might require like you to actually do a stream join to a static join. Like, I haven't worked with that use case, but they have those use cases, you know, in the real world. Obviously, there's also stream join which can be very complicated, especially when you are doing some clickstream analytics. You know, when you jump from this website to another website, sometimes they want to compare, okay, what did you do in that website? What are you going to do in this next website, so they can automatically tune the advertisement. So those are various complexities that we have. But for this class, we're just going to make it very simple. For autoloader, what do we need to do? If you have a use case where autoloader is the use case where if you have a data source, be it data is coming in your data lake, be it you're reading data from Kafka, event hubs, whatever it is, can you ingest this data efficiently in low cost? So normally, beforehand, we used to have this thing called structured streaming in Spark. And nowadays, structured streaming is no more a thing, because autoloader is nothing but structured streaming, but on steroids, right? Like, it's more like upgraded. So nobody needs to actually go into structured streaming. We will go over the differences though later on what are the advantages of this autoloader over the structured streaming. But one of the main things you have to understand is autoloader gives you exactly once processing. So this is one of the biggest selling points. How many of you remember when you are processing data from a data lake, and every time you ingest the file, you say, oh, I got to move it to archive folder, and you're dealing with those kind of things where if, let's say, the pipeline breaks when you are processing the file, you have to worry about, oh, did I send it to the archive? I should send it back to the incoming folder. Those file movements that you're dealing with, you have to write the code for. Those end up being things that might take your time and cause some headache. I've also seen cases where if you have so many files, right? So many files, like I told you the example where you have an IoT device. They're generating so many files that is coming into your data lake. You have thousands of files every 5 minutes. You might struggle with even to move the data from one folder to another to archive it. That file system operation can end up delaying your pipeline. Like that can become a performance hit. Not even the processing of the records itself, but just to move the data from one folder to another now becomes a bottleneck. So this structured streaming approach helps us to kind of solve that challenge with this exactly once guarantee, which means that it will handle that operation for you. When it processes the file, it knows what it processed. That way you don't have to worry about, oh, if my pipeline failed, will I need to figure out which file got processed or not? You don't have to worry about that. So this is one of the biggest selling points. And then also for the schema, most of us know, like when we don't have control over the source system, right? We don't have control. So one day you're ingesting files, the next day they add a new column in the source, and that becomes a big issue for you, and your pipeline might break. So with Autoloader, it helps to handle that. And these are some of the other advantages. When it comes to the scalability, the speed of process large volumes of data, Autoloader is the way to go. It's much better than structured stream because it can handle like up to millions of files per second. There is also the part about the cost. It's super cheap. It's more cheaper because now you're looking, it gets the files from at the directory level, not because the cloud, they charge you per file, and as you read any file, they charge you. So, but Autoloader comes with a more efficient way to know that the file got landed. I already talked about schema inference, so that's fine. All right, so let's look at the basic modes. By the way, any questions? Any questions on this so far? Because we're gonna jump into the demo in a second. Also. So yeah, ask someone to raise their hand. Yeah.
Hi Mezu, sorry, my question is, are the slides going to be available? Because I'm actually reading them and I'm finding them so interesting, and you're moving so fast.
Oh, sorry about that.
Are they going to be
yes, I will. Yes, you know what? That's a good point. I will upload the file
PDF
and make it available in that link, in that GitHub link that I shared. I'll do that. After this. Yeah. Let me actually do that. But do you have other, like, another question in terms of the concepts? Am I going too fast? I know if you are new to Databricks, I'm sorry. A lot of these things will be over your head because there's a lot of, I'm making a lot of assumptions that you.
Yeah. I know Databricks, and I used it for on a project where I didn't have any
Guidance. Yeah.
I didn't have guidance, so I had to kind of wing it. And luckily I was able to kind of create some data pipelines, but it was very basic, I have to be honest. Like, it wasn't sophisticated at all. It was mainly batch data that was updating like every day. And it was not that big of a data set. I used it mainly because it was very great at helping me get data from various sources, emails, from what is it, from a Hadoop on-prem server. Like, yeah, so it really helped. And I didn't know, so I'm learning about streaming now because I haven't streamed anything before.
That's great. And yeah, that's very fair. Yeah, I think you still will be getting a lot of value from this, because even one thing I'm gonna show you guys is that with Autoloader, right, it's not just for streaming. It has this version that works with batch mode as well. So it's really it can be used for both. But anyway, we'll get there with the demo. So first, I wanted to show you like the one of the main syntax changes is normally with the batch you say spark.read. With this one, autoloader streaming, you have to say read stream, and you have to put these cloud files thing. Don't ask me what what this means, but it's like the syntax, like to tell it that you're trying to do autoloader. And the other thing is, like I told you, this one, the trigger available now equals to true. This will help you run the stream to process all the files since the last time it saw any file, right? Like it's gonna process all the new files since the last time it processed. So, and once you finish processing it, it will stop. So that way you end up saving money. Also, it acts like a batch processing. We all know that if we had to do it without autoloader, we can still do it, but you have to now come up with your own logic of how do you know what files you process, right? Like, you have to now start building that logic yourself. But autoloader, you don't have to worry about that. It will keep track of those files. There is something called, I think, did I talk about it? There's something called a checkpoint concept that it uses to track that whatever files is processed. And there are two types of autoloader. One is the directory listing and file location, or file notification, sorry. So this is the most common one. If you are dealing with thousands of records, thousands of files in a minute or so, go with this approach, because it doesn't require you to set up any infrastructure, other services. It just comes native with Databricks. But if you are dealing with millions of files, if you have a big use case where you're dealing with millions of files per minute that you need to process, then you want to do something that is more efficient, which is this file notification mode. But it requires you to set up some additional services like event grid, do some configurations and all. We're not gonna touch that one because that's a different use case. So I think for this demo that we're gonna do, we will do it in the, we're not using the data lake, of course, because we are using just an Azure Databricks account, free account. But the good thing with Databricks free accounts, if you guys have learned of Unity Catalog, there's something called volumes, Unity Catalog volumes. So it's a similar thing where you can store like files within kind of a folder, and I'll show you in a second. So we're gonna use that instead of using a data lake. That way everything we're doing is on the Databricks free edition. And then we'll run our pipeline to push it to bronze. We're not gonna do the save and go. Then this is the basic syntax, right? That you'll see in a second. You will see, you specify the format. Is it a JSON file? Is it a CSV file? You can specify that. You need to pass in your schema location, because like I told you, one of the benefits of the autoloader is it's able to keep track of the schema. Like if there's a change, it can actually help you kind of detect that, either fail the pipeline or you can merge the schema for you. You can also infer the column types. You can do schema evolution, and this is the other checkpoint thing I told you, where you keep track. There's a location where it keeps track of which files it has processed, which files. Yeah, that way that if the pipeline breaks or it stops or you pause it and you want to start again, it knows exactly where to start. Yeah, this is for the file notification one. So best practices, I think we can come to this one later. But most times, just to, one of the biggest things with autoloader is to make sure that when you're ingesting those files, you run an optimize command on the delta table that you are doing, because with the streaming, it's running every, let's say, 5 minutes. So oftentimes it creates tiny files behind the scenes on your target table. So it's very important to run this optimize command quite often to make those tiny files become bigger and avoid over partitioning the data. That's actually a real world scenario like we had, because many people you ingest, like, because you are ingesting a lot of files, you are worried, oh, the table is gonna be big, let me partition, and you overdo it. If you over partition the table, it's also gonna be slow because you're creating so many tiny files in each partition, so it's not a good thing. But that's for the, if you are dealing with massive amounts of data. So that being said, let's jump into the demo. Let me put the link for the slide. Someone saying UC is not available in free edition. No, UC is available. Why are you saying that?
I was just checking and it was not allowing me to create the volume.
Why? Are you using the actual free edition, or you're using the one from the Azure or AWS?
I'm using my own account, but it's not because I'm not the admin, so it's not letting me create.
Yeah, that's we are using the Azure or AWS one, so that's why you're facing this issue. You can do this right now. Just go ahead to the link I put in the chat. It doesn't cost you anything. Literally, it's literally free. Let me see give me 1 second. I'm trying to find my my free edition stuff. So if you go to this website, right? If you go to this website, you click sign up if you're first time. You put your email, that's it. Like, it doesn't take. You can sign in with your Google account or create an email. And once you do this, you will get into the environment like this. And this environment, this way I told you to, if you go to the link that you get into the workspace, you go to the link that, all right, if you go into the workspace, you go to the link where I had the notebook pasted, and you can download it. Let me show you guys again. How do I copy this? So this is the link I put in the chat for the notebook. All you have to do is to download it here. Download raw file. Once you download the raw file, you go to your workspace, let's say here. You can go to your workspace under your users, whatever is your email. You can right click, I believe, right click, right, and import. You drag that file that you just downloaded in here, and that's it. Once you open it, you're gonna see this notebook. And then you open this notebook, it's gonna come out, and you can start a cluster. So it gives you a free serverless cluster. So let me give you guys a little bit, like 2-3 minutes, in case you are doing this. I need to check something real quick. I'll be right back. Give me 1 second. Sorry, guys. I had something on the. I was baking some food. So, did anyone try this? Are you having issues?
So with the serverless cluster, right, on the free edition, obviously the first line is going to fail because that does not exist in our own environment.
Yes,
right?
yes.
So second one, create new autoloader. I'm running that now.
Yeah, you can run this one. Yeah, me, I had to run that for me because it's I had created things in the past, so I think it should fail. Yeah, it should fail, so that's fine. Then let me run this one. So this is to create a catalog and set up our catalog. So that worked, and you can validate that if you click on your catalog here. You can validate that the catalog got created. So anyway, my computer is kind of slow for some reason. Let me turn off my video because maybe that's fine. So the next thing is that this like setup process, right? So the volume, I hope some of you might know what the volume is. Here's where I need you to kind of do some manual adjustments. In the part, because we create this catalog, right? Just to help you validate as well. This new autoloader. Under this autoloader schema, this is the volume, right? So this is the thing you can copy, right? You can copy it from here. This is the volume part. It's a similar concept with the data lake part. If you are using Azure Data Lake, you can copy it from here. And all I have to do is put it here. So this is where we'll dump all our, because what we're gonna do, we're gonna generate some files and then also dump the files. So as you are doing this, also you see this part, also update this one. Also copy the same thing over here at the top, because I hope some of you might know how to do this. Is if you have a notebook and you want to pass in parameters, you can do that using this widget, this widget 10. So we picked JSON, right? JSON will be our data format. You are welcome to pick CSV or Parquet, but whatever you pick, be consistent, like pass it in here. So now all you have to do is, once you have done this part to the correct part that you copied from here, now you can run this step. It will automatically, create the paths for the different things. Like as you can see, we have this one is for where we'll dump our inputs folder incoming files. Like we are kind of simulating simulating an environment where these files are landing into our data lake from an external source. Just like it will be in the real world, they will be dumping those files into this subfolder for you. Then here is the checkpoint directory, like where we'll store Databricks Auto Loader will store the checkpoints of which file is processed, which file, where did it stop. Then it will also have a location for the schema to keep track of the schema of the files. And this is for the tables, the bronze table and silver table. Like I said, we're just gonna do the bronze for today, but have the silver table as well. All right, so let's run this.
So once we copied, we should copy that part, and we should put that in the base part widget, correct?
Yes. Copy and put it there. I think if it's your very first time, it will automatically put it there. But because I've done this multiple times, I'll just copy it manually. Input. So once you do that, hopefully you don't have any errors. You can now, this is where we generate the file. We have this piece of code that takes in the format, the JSON format, and it takes in the output where it's gonna, this, inputs location, where it's gonna dump those files. So what I'm doing is, oh, I made a mistake, guys. So what you have to do, please change this to 0 to 20, if you don't mind. Change this to 0 to 20. So what it's gonna do is gonna generate some just dummy file, like a dummy file with an ID column, a category column, amount column, and ingest timestamp column, kind of randomized, but it will go from 1 to 20, and it's gonna put those into this output folder. So
I have a question. Do we have to? So when we copy that volume part, do we need to also update those widget texts in there, or to automatically pick it up?
Automatically, yeah.
So I don't need to update line 1. That's what I'm saying. Do I need to update line 1? Yes. Do I need to update that part? Yes.
Yeah. Update it with what you got from this one. The one you created. Yeah. This is the only thing you need to update. Once you update it, you run it, it should print it out like this. Anyone else have an issue or talk? Let me know.
Hi, sorry, I just need to ask, in terms of the data that's in the volume in the JSON file, it's a static file, right?
Yeah, so when we generate, have you run this already?
So I'm having issues, I'm trying to fix them now, but I just want to make sure that that file in volumes, it's a static file, and then will it also come through when I clone your repository?
Yeah, if you clone my repo, so I'm showing you right now, like
Mm-hmm.
if I run this, let me just run it so you'll see what I'm saying. So this will generate a bunch of
Oh,
files.
a file in, okay, I get you. It's going to generate a file in volumes. Okay, awesome.
Yes, yes. A bunch of files. Yeah, just gonna generate. So always like to see the latest thing, you always refreshing. So you see the input. If I look at that, I should see the JSON. Inside the JSON, I see these files. So these files, this is what it created. And these are all JSON files. You can actually do a preview as well. You can preview how the file looks. Like, yeah, there's an ID column, category, amount, ingest, timestamp. So this is how, in the real world, this is how the files, obviously, we are doing it's just a sample, but in the real world, right, an external source system, it could be IoT hubs, it could be, some people use Kafka to dump the file, some people use chain data capture tool, right? That's another use case. I keep forgetting to tell that use case. Like, it's actually very common when, if you have data in a source system, like from a relational database, your likes of Oracle, SQL Server, and you want to, so there's something called chain data capture that replicates that, source database data into your like data lake. So those tools, they can also do something like this, where as it's seeing any changes in the database, like any table, any update, insert, delete, it's gonna write those as files. It could be JSON files, CSV file, whatever. It's gonna write those as files into your data lake. So as the time is going, you just be seeing it spitting out these kind of files into your data lake with the, obviously, with the respective column names for that table. So think of this as your source. This is what is going on from the external sources creating all these files. So once that is done, we can validate. We can read those JSON files and display it. This is just for validation's sake, that it actually created 20 files. So I can see that I didn't sort it, but it has 20 rows. You create those 1 to 20, right? Oh, actually 0 to 19, not 1 to 20. So this is good. I see all the data this is my incoming data is in JSON format. So my goal is to do what? To ingest it into like my bronze zone as a delta table, right? So that I can do downstream analytics, right? Like, so that's my goal. I want to ingest this because remember, it's coming every 5 minutes, every 1 minute. It's a lot of files coming in. So I want to use Auto Loader to process these files and write it into my Delta table for downstream analytics. So this is the directory listing mode. So this is the way. So we specify the format like I showed you. It's already default to JSON. This is the syntax, right? You say raw stream read spark.read stream. Very similar to the batch mode, but the difference here is the read stream and you have to say cloud files format. You specify the data format. It's gonna be JSON file format. The schema location, right? Schema location means what? Where at the top we already defined it, right? We already told it that, hey, for the schema, use this folder to store the schema, right? And infer columns will be true. And when we specify the incoming folder, which is this one, right? This is the incoming, the input folder where the input files are saved. So we say load from this directory, and then so this is the data frame we create to actually read the data. And remember, Spark is lazy execution, so you're just gonna read this thing. You run for 1 second. Then the next thing is we're gonna do right away is to write it to the Delta table, but we're gonna write it to this part, the bronze part, the bronze zone. Now, there is also an option to directly write to the actual like the Delta table, because Delta file, Delta table, they are pretty much the same. The only difference is Delta table is when you actually have the schema around it, like you actually create the actual table name and all. That is what Delta table is. But for now, we're just gonna use this syntax to write it to a Delta file in a particular directory that we already specified at the top. And as you can see here, this is the checkpoint. We are mentioning the checkpoint that we also specified at the top. For now, we say merge schema is true because we are trying to, you can remove this if you want, but for now, we want it to be able to eventually, if there's a new column that got added in the source, you should just append it. I don't want it to break my pipeline. So output mode append means that I just want to keep adding the data. There are different output modes, but append is the most common, to just keep adding the data as it's coming from the source. It keeps appending it to the target Delta table. And trigger available now. This is what I'm saying. For the free edition, if you try to do the one that says processing every 15 seconds, it's gonna break because it knows that it doesn't want you to spend too much money. So available now is the only one that is allowed under the free edition. But if you have your own like Azure account, you can change this to process every 15 minutes or 15 seconds, sorry. So every 15 seconds, it's gonna trigger it's gonna process, check if any new files are there, it's gonna process it. But for now, we do the easy and cheap one available now. So let's run this. I don't know, why did I write this like this? Okay, yeah, it's just to execute it. All right. And also, one thing that we didn't do is when you are doing streaming, it's very important to also give your streaming query a name. So normally at the because when you have a production workload, right, you see that, you can be running your own streaming job, I can be running mine, and at the end of the day, if I want to look at the logs to understand what's going on, like, I don't know, does the free edition give us the Spark UI? It should. You can see some performance here, but it could give us some details. But the point I'm trying to make is sometimes when you put a query name, it's easy to identify your own query and know that what is going on. In case it's running for a long time, you can easily identify your own streaming query by this. If not, you get some default alphanumeric stuff. So we just process the first these files that we generated, and now we can actually validate. Go to this Delta table and actually validate that it ingested all of it. My bad. I made a mistake here because I'm using the wrong file path. I can copy the correct one here. But you guys have to do that as well. You have to copy the correct one. Okay. I'm making more mistakes. Actually, this is the correct one. Bronze parts. Any questions so far? Anyone? Everybody following? Are you guys stuck somewhere?
I am stuck. Sorry, I do have a question with regards to AL underscore catalog, right? If I understand it correctly, right? I'm start. You create a catalog called new auto loader, right?
Yeah.
So this AL catalog that you're dropping at the beginning was never created.
Yeah. Don't run that. Just
Sorry?
delete. I said just delete that line or don't run it. Just run this one.
It's just that when you're doing the setup and the first line, right, which is dbutils.widget.text, base path, it says volume.
You have to,
should I change that?
Yes,
okay.
You have to change that.
Okay, cool.
You have to change that to the new one. And did you know? Did I show you? So if you go to catalog here, right? You right click to new tab. You're gonna get this page. And you can now find the new autoloader catalog. And you can drill down under the schema. You find the volume. This is the volume, autoloader volume. And you can now copy that folder. So you should just copy this just up to here. When you click it, you're gonna get up to this point. Make sense?
Yep.
Yeah. So that's all you need to do is to copy that here and make sure that's the same thing that comes here. You can copy both places, but normally for the first time it should be, but make sure that that is the same thing that you copied over here.
Auto Loader, I see it.
Yeah, makes sense, right?
Mm-hmm.
So you get these things, it should look like this, then the rest should be the same. Yeah. Let me know if you still stuck. So for those that are still doing this, so we got this, we're able to validate that we ingested the 20 records into a delta table that's stored in this brown zone, and we can display the records. It looks good. So now, just for your own understanding, and from what I'm telling you is that, as you can see in my inputs, those files that I created initially, they are still there, right? They are still present in the input bar. But if I run this again, if I run step 2 again, you will notice that, it will not duplicate my target. If I run the target, it's not gonna, it's not gonna do anything because it knows that it already processed these files. So it's not gonna create duplicates in my data table. But if you are doing batch on your own, you may create duplicates. Go ahead. Yeah.
Thank you. Sorry, I'm like bothering me. I am still on the setup. My variables input path, checkpoint, schema lock, bronze path, and silver path. Why do they not want to override when I've added?
Are they saying AL catalog or whatever?
Yes, they don't want to override the base path.
So did you do this one? Are you seeing my screen?
Yeah.
Did you copy the same thing from here into this part? This one?
Oh, at the top. Okay, so this is what okay. I missed that. I didn't do that. Thank you.
Yeah, do that one. That's it.
And then do I save? Like, what do I do?
No, you don't need to save it. It's automatically saving. So just run it again. Run it again. It's gonna correct. Did it work?
Let's see. Yes, it did. It did. It did run. And then we were able to generate. Yeah, we were able to generate the files. Thank you.
You're welcome. So, as you can see, like I just showed you, that's the power of Auto Loader, right? You are able to process files without worrying about any duplicate processing because it processes exactly once. Now, moving on. I'm not running this anyway, but moving on to schema evolution. So I can decide to give me a second. Hold on. All right. Let me change this, guys. I'm changing this to 21 to 25. So I can decide to actually add a new extra column here, as you can see. Wait, what am I doing on? Then kind of messed up. Yeah. That's my ingestion. Again, you still need this one. So imagine if I create a new file that this new file added this extra column, right? It's adding an extra column, and I'm putting it in the same folder because let's say the source decided to they change their schema. So you will see that one of the good things about autoloader now if I go to my inputs folder, let me show you those files. Those extra new files got generated. If I do a refresh, you'll see that I've added those extra new files. So let me show you now how it looks. So you can see that, right? Added extra new file. So now, when I added these new files and I run my reprocessing, if I didn't use this nice schema through, the pipeline will break. But if I use the nice schema I put through, then the pipeline will succeed. So let me reprocess the files again. So it's gonna pick up those new files and then put it in the Delta table. So actually it broke. As you can see, it actually broke because it's complaining that these new files are not there. So what it is just telling us that these new files is unknown to it. So I just have to do a retry. If I retry it, it will now work. That's the way it behaves. The first time it's gonna fail to show you the error. Then the second time, the retry, it will work. That way,
So
you get
do you
to
need
know.
to have like a retry logic in the real world, right? You have to kind of like build in a retry logic.
Yes, yes, yeah. You can do a try catch block.
Try catch, yeah.
Or you can also do it at the orchestration layer, like Databricks. When you look at the jobs and all, they have that thing built, like to retry at least once. That's another day, you know. But you can play with it. You set it up. You see here. Don't know. Somewhere here they had it schedules. There's a retry thing here, but that's another thing. But yeah, but you can do the try catch. Yeah. So we can now test, do our, again, validation. Wait, what? Okay, yeah, I keep making that mistake. I need to copy the correct one. So as you can see now, you see this extra, right? It started to appear for the new records. So that's how schema evolution works. Finally, what I want to show you is a bit advanced. So like you can skip some of these things. Here is where, like, actually this is like a more real world scenario, because in the real world most times you are not just doing append because like data from the source can be, how will I say, it can be, you can have duplicates, right? You can have duplicates, you can have late arriving data, like I told you. You can have network issues where the data from 9 a.m. comes at 2 p.m. And you can have duplicates where the exact same data gets sent to you twice. Like they sent it twice because some network issue. So those kind of things means that if you just do a normal append, you're gonna have issues. If you just append whatever you see, you're gonna have issues because the data will not be accurate. So you kind of need to implement some level of batching, which means you want to generate like a way to deduplicate data. Like in each time you process incoming files, if there's any duplicates, you want to remove it, get the latest version based on the last modified date. In addition to that, you want to do a merge. You just don't want to just insert into your target table. You want to do a merge. So if there's an existing record based on the primary key, you're just going to overwrite it. Or if it's a brand new record, it's inserted. So that's very important because, like I told you, that's a real world scenario. Because anything can happen, right? So now let's do something like that where we will first generate some duplicate records, because we already have data. We'll first generate some duplicate records by running this last function twice. My bad. Don't run this one, guys, sorry. We can use the one above because I needed to change this thing. Let's use this one. Not the one with schema evolution, but the one with. So what I'm gonna do, I will change this group to 10. I'm gonna generate like new records, but they'll be duplicate. I also generate 2 to 5. so that in a given batch, as you can see, when I run this now, you see what I'm saying. Let me order by. I just want to show you what I'm talking about. So as you can see, I have duplicate records. This can be in the real world. They can send you the data. Not only is it late arriving, but also duplicates, right? Because I've already processed this once earlier, but I'm still getting this one twice, 3 times, or whatever. So the point now is that once you're getting this kind of records in your data lake, how do you process it in real time? So there's a difference. If it was in batch mode, it can be straightforward, but with the real-time processing in autoloader, you have to be aware that, like I mentioned when we are doing the theory section, it's not just a table. You have to think in a stream manner, right? You cannot just, do a deduplication without doing it in a batch method. So what we have to do, the same syntax is almost the same, but we have to do, if you're trying to do something like a merge and deduplication, you have to put it in a function. You have to put it first, you have to create a function, right? Create a function, and you put this is the windowing function. I don't know if you guys are familiar with that, where we do get the latest version for a record based on the primary key. So we do that windowing. You get the what's it called? You filter base. First, you get the window partition by the ID, and you sort by the timestamp, and then you filter for the latest record based on the timestamp. So this will dedupe the current batch, and then using the deduped data frame, you will now use that to do your merge into your target. So this is the merge statement here, and you wrap all this into a nice function. And then when you do your streaming, you still say the read stream, put the checkpoint on all that jazz. Okay, but don't forget this part, right? You do the read, you read the stream, put the whatever format, schema location, and the incoming data folder. And here you now do the key important thing is this for each batch. That's the main thing you're doing differently. For each batch, you mention the function name. It's gonna take that current batch and run it through this function before it actually appends it to your data frame, in the prompt. So this is the big difference. And yeah, ask your question. Go ahead.
Yeah, I was just curious to see where you applied it, because when you define the function, right, there are 2 parameters or 3 parameters fitting into that function. I'm just curious to see how those are like. But when you use that function, I'm not seeing where you call those.
Yeah, yes. So see, that's the only question I had. But this one for sure, you just, number one is this is just most of it is just the syntax. That this one for sure is implicit in the way that it knows it's using the actual batch. I think these parameters are kind of sort of like they call it implicit or some kind of default values is using, because you are using it in a streaming method. This micro batch parameter signifies the current batch of the streaming that you are doing. Like, let's say for this available now, like I told you, it's gonna process all the files since the last time. So that batch, that data frame that you got from here is what is using to do this. The batch ID is some internal ID you generate. I don't know why most of the syntax I've seen, we don't actually end up specifying these things. But I'm just curious, actually, now that you ask, let me see if I say a raw string. I just don't know what to pass for the batch ID because I don't have that value. Will it actually work? Let me see. I'm just curious now. No, it doesn't work. Yeah. So, well, we can Google it, but I don't really see where they ever like specify that. They just always write it like this. The batch ID never gets used in even inside this function, but it's normally specified. But that's something we can look into. Actually, don't have that answer, but I just assume that's part of the syntax. Does that help?
Yeah, that's fine. I mean, I understand. That's fine. Thank you.
Sure. All right. So that's really the end of it. You don't have to worry about cleaning up, but initially, the first time I ran this on my own, Azure account, so I had to worry about cleaning up because I don't want to cost, I don't want to spend money. But any questions? Because this, I know it's a lot of stuff, but it just shows you the basics so that in case you have that use case, like I told you, where you have a CDC tool, anytime you have a lot of files coming into your data lake and you want to have something to help you process the data efficiently, you still end up, the goal is just to get the data from the incoming, be it JSON, CSV packet, whatever it is. You want to just process that file and push it into a Delta table. Autoloader is a good thing to use because, like I said, it can run in batch mode. It doesn't have to be a streaming mode exactly, but Autoloader is a good option. Be it change data capture, be it like IoT devices, and all that kind of stuff. Let me check. Does it work with Kafka as well? I think that Autoloader is mostly for. I think Autoloader is mostly for data in a data lake, like files. If you're actually dealing with Kafka, you have to use the Kafka connectors. It's not gonna be Autoloader, but with Autoloader is mostly for files that are in your data lake. Yeah. So any questions closing remarks and all?
Yeah, this is really good. Thanks. Okay.
Yeah, you're welcome. You're welcome. Yeah. So just to round up, I'm glad you guys learned something. Kind of showed you something you can use in your project if you need to. And there's obviously more to it. Like I said, we didn't do much transformation, like windowing and all those kind of stuff. If you're actually doing streaming, there are other things involved. But this is just some basics. I do want to put my own plug for I do have a bootcamp going on where like I say, like I help students just like we're doing today. We kind of go through some concepts in Databricks, not just Databricks, but data factory as well, end-to-end data engineering. Try to give you my perspective, give you the perspective of what's important. That way you can feel more confident going into roles, or you hope or you can even break into data engineering roles. So let's say you're an analyst and you want to start working in data engineering. I have that bootcamp. I'm already almost done with this bootcamp currently that I'm doing with a bunch of students, but I might have another one coming up next year, and I will let you know. But if you don't mind, if you want to keep in touch with me for whatever reason, just to be, what's it called? Just to be, what's it called? Just to be in touch for any reason. I do have my LinkedIn. I'll drop it in the chat, and follow me on LinkedIn, message me, and also join my mailing list. See, this is where I always struggle organizing myself. I have so many links. Okay, go ahead. You have a question?
Thank you so much for the session. I don't know if you're finished. Sorry.
Yeah. I'm pretty much done. I'm just giving my advertisement plug.
No, it's working. I was hoping that after this call, we could just have a quick chat, if that's okay.
Sure.
After everyone is left, sorry.
Sure. So yeah, I'm just giving the rest of the folks my links, so that way, how do I? That way you can actually like follow along. So I do blogging as well. I write a lot of blogs, like different things, anything that comes to my mind. So some of it is good, some of it is like whatever. But it helps, to kind of keep you up to speed with what's going on in the industry. Finally, I also have my link tree, right? Yeah. You can follow me on all platforms. Mostly I'm active on Medium and LinkedIn. I'm not as if I have YouTube channel as well, but I don't do as much videos as I should. So, but you can feel free to message me. I have my website as well, but I actually need to update this. I have a new website coming up. But yeah, follow me, reach out to me. My email. Did I give you guys my email yet? Obviously, you have my email from this calendar, but I actually have an official email. Where is that email? I forgot where it is. Just one more second, guys. Don't bear with me. Let me get you my email address. Where is that email? It's actually on my phone, in case you need to contact me officially. But you guys feel free to drop if you already, some of you already know me, so there's nothing much new. Feel free to drop and enjoy your Saturday. Yeah, my email is, I can't even remember my email. Staff.com. All right, so that's it, guys. Have a good Saturday. So yeah, stay on the line. So what do you go by? Oh no, what's your name? Do you go by?
It's Nomfundo.
No Fundo.
That's my first name, yeah. And then Kuala is my surname.
Okay, Fundo. All right. Are you from, like, how did you hear about this course?
I follow you. I follow you on LinkedIn.
Oh, nice. That's
Yeah.
good. Nice. That's good. Yeah. I don't know. My LinkedIn has been not as optimized. They want me to pay, right? Like, I used to get a lot of, like, you could say reach. I used to get reach a lot,
Yeah.
but nowadays, when I post, I don't even know. It's like only 100 people see the.
Yeah, they do want you to. They definitely want you to pay. They definitely want you to pay.
Yeah, and it's so expensive, man. Like $800.
Like you have to build all the stuff yourself and find ways